Alright, so today we're learning about equivalent fractions, and like I was just saying, in order to be able to compare fractions, we have to be comparing fractions of the same size. So we're looking for the same denominators. Alright, so let's look at example 1. In example 1, it gives me the number of goldfish to the number of fish. Okay, so I'm comparing 2/10 because 2 out of 10 fish in the tank are goldfish. And then the number of groups of 2 goldfish, which is 1/5. Okay, well, as it is right now, I can't necessarily compare them because my denominators are different. One is 10 and one is 5. But can I reduce 2/10? Can I reduce 2/10 to what? 1/5. So I just want you to show that you've reduced it. And now, yes, 1/5 is equal to 1/5, okay? And I would just box in my equal sign to show that they're equivalent. Okay, so example 1, here's what we're learning. We're learning how to reduce fractions to simplest form and then tell whether or not they are equal. All right, so let's do... what if I had the fraction 14 over 42 and 1/3. Okay, well, if I'm comparing them as it is, you can write them on top of each other or next to each other. It really doesn't matter. But if I'm comparing them, I can't just say, oh, well, 14 is bigger, or these are equivalent fractions, or these are not equivalent fractions. I have to first reduce them to simplest form. Can I reduce 14 over 42 by anything? What can I reduce it by?
3.
I can reduce it by what?
3.
I can't reduce it by 3. I can reduce it by 7. Okay, now you can reduce it by a bigger number, but let's just say 7. So if I divide top and bottom by 7, I get 2 over 6. But is 2 over 6 simplest form?
Nope.
It's going to be 1/3. So now that I've shown both fractions in simplest form, would I say that they are equivalent fractions? Okay, I would say yes, they're equivalent. Yes, they're equivalent. So anytime I'm asking you, are these fractions equivalent, what's the first thing you need to do?
Simplify.
Reduce, simplify to simplest form, and then if they are the same fraction, they're equivalent. If they're different fractions, they're not equivalent. All right, so what if I had 15/20 and 24/30? And I want to know, are these fractions equivalent? Well, again, all right, I need to simplify. Okay, so 15 over 20 reduces to what? 3, close, 3/4. Okay, and then 24 over 30 reduces to... Hold on. 4 over 5, 4/5. So are these fractions equivalent?
No.
So I would say no. Okay, and that would be my answer. And my work is reducing them to simplest form. All right, so that's example 1. I'm reducing fractions to simplest form and telling whether or not they are equivalent. All right, questions? Okay, example 2. In example 2, now I'm writing equivalent fractions. So let's say I had the fraction 4/5. Okay, if I want to write an equivalent fraction, all I have to do is multiply the top and bottom number by the same number. Okay, so you really could choose any number you wanted. You could choose 5, you could choose 10, you could choose 2 or 3. But whenever you have these, I'm going to ask you to write 2 equivalent fractions. So let's just multiply top and bottom by 2. I do want you to show what you're multiplying by. So if I multiply top and bottom by 2, here's what I'm doing. I'm making the numerator and denominator bigger by the same number. Okay, so if I were to reduce 8/10 to simplest form, what would I get? I would get 4/5. So am I changing the value of the fraction? Not changing the value of the fraction. All I'm doing is writing an equivalent fraction. If I reduce it to simplest form, I should get 4/5. All right, so I've written one equivalent fraction. Now I just need to write another one. So I can multiply by 3. Last year, a lot of my students, they just picked their standard numbers. They multiplied one by 2 and one of them by 3, and they created their equivalent fractions. You can do that too. I like using 2 and 3 just because they're very basic. You don't want to get into huge numbers because you don't want to make a mistake multiplying. All right, all we're doing is creating equivalent fractions, so as long as we multiply top and bottom by the same number, you're going to have an equivalent fraction. So if I have 12 over 15, now again, if I reduce 12 over 15, I'm going to get 4/5. So I'm not changing the value of the fraction, all I'm doing is creating an equivalent fraction. What you'll do on your homework tonight is you'll box in your 2 equivalent fractions. You won't get credit unless you show me what you multiplied by to get your equivalent fraction. All right, questions? Look at another one, okay? Now, what if we had this, let's say 16 over 20 is my fraction. Okay, now, I'm going to tell you to give me at least 2 equivalent fractions. But now, is this a fraction that could be simplified?
Yes, 4/5.
Yeah, I can simplify it. Now, with 4/5 here, that was simplified, so my only option was to multiply to create an equivalent fraction. Well, here, since it can be simplified, I can either multiply by top and bottom by the same number, or I could divide top and bottom by the same number. So what's one number that this could possibly be reduced by? Doesn't have to, okay, it can be 4. Doesn't have to be 4. You could also divide it by 2. So either way, again, as long as you are multiplying or dividing by the same number, you're creating an equivalent fraction. 8 over 10 is going to be an equivalent fraction. All right, so you could divide one and you could multiply the next one times 2 over 2. That would be fine too. Could you have divided the second one by 4?
Yes.
Does 4 go evenly into 16 and 20? Yeah, it does. So you could have divided both because there's 2 numbers that go into it. As long as you're doing the same thing to top and bottom, you're creating an equivalent fraction. So guys, on your quizzes, you're going to have different answers. Your answers might be different from your classmates, but it doesn't make it wrong. There can be a lot of different answers for these. All right, so there's my 2 equivalent fractions. All right, in example 3, they made this an entire example. Simplify the fraction to simplest form. All right, so if I had 8 over 28. Now, when I'm simplifying a fraction to simplest form, hopefully this is review for you, but I need to make sure I can divide top and bottom by the same number. Okay, hold on. So what's one number that I could reduce by? I could reduce by 2, but is there a bigger number? I could reduce by 4. So you do want to try to pick the largest number that goes into both of them, which I call that the greatest common factor, which is why we did GCF before this lesson. Now, let's just say, and I do want you to show what you reduce by. Let's just say I picked 2. I just forgot that 4 goes into both of them. I should get 4 over 14. And if you box this in as your answer, you'll get it wrong. But hopefully you see, oh, well, 4 over 14, that's not in simplest form yet because I can reduce again by 2. And I can get 2 over 7. Now, if from the beginning you catch that you can reduce by 4, it saves you work because you only have to reduce one time. Does that make sense? All right, so just make sure that whatever you're boxing as your final answer, make sure that's totally and completely simplified, that you didn't forget to simplify it all the way. All right, and then what about 8 and 15? What about 8 and 15? Can I reduce 8 over 15? Is there any number that evenly goes into both of them? No, there's not. So if they don't share, this is a little bit of review, but if they don't share any common factors at all, do you know what I call those numbers? What do I call those numbers? This is from Friday. Do you remember what I call those numbers if their only common factor is 1, Alex? I call them not prime, but relatively prime. They don't share any common factors except 1, meaning it's already totally simplified. I would say this, if I can't simplify it anymore, I just box it in and I say that the numbers are relatively prime. What I'm saying is there's no number other than 1 that can go evenly into these numbers. So 8 and 15 are relatively prime. All right, questions on example 3. Now, in example 4, it says, at a girls' basketball game, the home team made 14 out of 22 free throws. How can I write 14 out of 22 free throws as a fraction?
14 over 22.
14 over 22. They made 14 out of 22 total. My total goes into my denominator, and my part goes in my numerator. Hold on. And then it says the away team made 10 out of 25 free throws. Okay? Now it says write the number of free throws made by each team as a fraction, and are they equivalent? Well, can I just compare them as it is and say, this one's bigger because 14's on top?
No.
What do I need to do?
You have to simplify them.
I have to simplify them. Okay, so,
14, 22.
yep, I divide by 2. 14 over 22 equals 7 over 11. And then
2/5.
this is going to be 2/5. So are my fractions equivalent?
No, ma'am.
They are not equivalent.
No.
But look, I've got to have work. If all you say is yes or no, then you're going to lose all the points. Okay, yes or no, that's a simple guess. I need to actually see your work. So reduce both fractions so I can see that you actually know what you're doing. Yes, exactly. So you actually know what you're doing. You're showing it. All right, and if you understand that, that's everything you need to know for 4.3.